Good afternoon, everyone. Thanks for joining us. Welcome back. I'm Steve.
And I'm Scott.
And together we're Backyard Musings, Apple Valley, the science and technology channel. We're going to blind you with science.
Yep, we're talking about an interesting one tonight, or this afternoon. It's about moss.
Yeah, very interesting.
You can get excited about that. So,
researchers discovered that moss spores can survive nearly a year exposed directly to space. So just put it on your spaceship and go to Mars, Despite intense UV radiation and temperature swings, most spores remain viable when returned to Earth. Their protective casing acts as a natural shield, enabling resilience even scientists didn't expect. The results open doors to using hardy plants for future off-world agriculture. Would you like to know more?
Okay, mosses, or mossi, I guess, are known for their ability to flourish in some of the harshest locations on the planet, from high mountain ranges like the Himalayas to the scorching terrain of Death Valley, which is right here in our backyard, as well as the frozen Antarctic tundra and even the cooling surfaces of active volcanoes. Their remarkable toughness inspired the researchers to send moss sporophytes,
yeah,
which are reproductive structures that contain spores, into what may be the most inhospitable environment of all, outer space. Here we go. The study, published in iScience November 20, just a couple days ago, 2025, reported that more than 80% of the spores endured 9 months outside the International Space Station and returned to Earth still able to reproduce. This marks the first documented instance of an early land plant surviving long-term direct exposure to space.
Yeah.
Can we make it edible?
Yeah.
We can.
Most living organisms, including humans, cannot survive even briefly in the vacuum of space, says lead author Tomomichi Fujita of Hokkaido University. However, the moss spores retain their vitality after 9 months of direct exposure. This provides striking evidence that the life that has evolved on Earth possesses, at the cellular level, intrinsic mechanisms to endure the conditions of space.
Fujita first began considering the idea of testing moss in space while examining plant evolution and development. Mosses seemed exceptionally capable of settling in places that challenged most forms of life. Quote, I began to wonder, could this small yet remarkably robust plant also survive in space? Okay.
To explore this question, Fujita and his colleagues exposed Fiscomitrium patens, also called spreading earth moss, to a simulated space environment that included intense UV radiation, extreme temperature variations, and vacuum level pressure. The team compared the survival of 3 moss structures: protonemata, juvenile moss, brood cells, specialized stem cells that form during stress, and sporophytes, encapsulated spores. Their goal was to determine which form had the highest resilience under space-like conditions.
Another quote here. We anticipated that the combined stresses of space, including vacuum, cosmic radiation, extreme temperature fluctuations, and microgravity, would cause far greater damage than any single stress alone. This is a quote by Fujita.
Their results show that UV radiation was the most damaging factor. Sporophytes were dramatically more resistant than the other forms. Juvenile moss died under severe UV exposure and extreme temperatures, while brood cells performed somewhat better. However, the spores inside sporophytes displayed approximately 1,000 times greater UV tolerance. They also remained viable after enduring negative 196 Celsius for over a week, and after spending a month at 55 Celsius. That's pretty hot.
Those are some extreme temperature changes
there.
So,
the moon.
Yeah. The researchers believe the protective casing around each spore shields it by absorbing UV radiation and creating both physical and chemical protection for the spore within. They suggest that this adaptation likely helped early bryophytes, the plant group that includes mosses, more from aquatic habitats to land about 500 million years ago. Wow. Enabling them to withstand multiple mass extinction events through Earth's history. To determine whether this natural protection would hold up in actual space conditions, the team then launched sporophytes beyond Earth's atmosphere.
Here's a question. Riddle me this. Do you think a cockroach could survive in space?
And, I'd give it a shot. I'd like to
Just
take
see?
them all and just send them up to space. Just give it a shot. But I'm sure they could. They are, they're pretty resilient little critters.
I know. In March 2022, hundreds of sporophytes traveled to the ISS aboard the Cygnus NG-17 spacecraft. Astronauts mounted the samples on the station's exterior, exposing them to open space for a total of 283 days. The samples later returned to Earth on SpaceX CRS-16 in January 2023 and were brought back to the lab for examination. Quote, "We expected almost zero survival, but the result was the opposite. Most of the spores survived," says Fujita.
Wow.
"We were genuinely astonished by the extraordinary durability of these tiny plant cells."
More than 80% of the spores lived through the entire trip, and all but 11% of those survivors germinated once they were returned to the lab. Tests on chlorophyll levels showed normal readings for nearly all pigments, except for a 20% decrease in the chlorophyll A light-sensitive compound. Yet this reduction did not seem to affect the spore's health. Quote, "This study demonstrates the astonishing resilience of life that originated on Earth," says Fujita.
Wondering how long the spores might have lasted beyond the 9-month exposure, the researchers used their data to construct a mathematical model, of course. Their estimates suggested that the spores could potentially survive up to 5,600 days or roughly 15 years under similar space conditions. They stress that this is only a preliminary calculation and that additional experiments with larger sample size will be needed to refine those predictions. Send me your money.
Yeah. The team hopes their findings encourage future work on how extraterrestrial soils might support plant growth and spark interest in using mosses to help build sustainable agricultural systems beyond Earth.
Quote, "Ultimately, we hope this work opens a new frontier toward constructing ecosystems in extraterrestrial environments, such as the moon and Mars," says Fujita. "I hope that our moss research will serve as a starting point." I wonder if moss can be turned into algae, which you can synthesize algae as a protein.
I know it grows on the north side of trees.
Yeah, and if you could make it strawberry or cherry flavor, that would be great.
Yeah. Maybe a little tri-tip flavor or something like that. That would be good too, right?
Hey, folks, we're 3 subscribers away from 700, and we've been like this for months, and we're demoralized.
No, we're not. No, we're not.
So we want you to run, don't walk, and find 3 people to smash that subscribe button.
If you each found 3 people, we'd be over 1,000.
Right?
Right? If everybody each found 3 people.
That's a lot of pressure, man. Okay. Hope you enjoy your Sabbath. We'll catch you on Monday.
Yeah, and we appreciate you listening and subscribing and all that stuff. So thanks for everything. Take care.